Hello and welcome to this video out of my series Networking Basics. I'm Wolfgang Tremmel from the DE-CIX Academy. If you're interested in more videos, have a look at our YouTube channel or check the DE-CIX website at decix.net/academy. This video series Networking Basics explains the foundations of Internet protocols and communication in the Internet. Today the topic is, well, not so very basic, but please keep on listening. The topic today is called ping considered harmful for network monitoring. If you miss some information, please watch the videos about IP and ICMP first, because I'm explaining in these videos what you need to understand today's video when I talk about ping and network monitoring. My history was also customer support. I was working in customer service at DE-CIX, and the following dialogue, well, it didn't happen literally, but similar things did happen in customer service. So a customer calls and says, hey, we monitor some packet loss towards any target, anybody else in the network. And the help desk asks back, hey, how do you monitor this? How do you monitor the packet loss? And the customer says, well, we constantly ping their peering router and we see about 3% packet loss. You do what? Okay, yeah, quite a reaction from customer service, but well, and again, the customer says, well, even if we monitor this packet loss with ping, everything else looks fine. So we don't even have a clue what's really happening. And this video, I'm trying to explain why this kind of monitoring is a bad idea. So let's talk about ping first. Ping exists in IPv4 and IPv6. And you might already did all that. You ping to check if a system is kind of alive, if it's up and running, if it's replying to a packet, if you send a packet, a ping packet to it, if you get a reply back. And like I said, alive, that means in this case, reachable over the internet. So if you do that, then, well, ping must have a mechanism to send a packet and to process the reply. Because it's not only sending a packet, you also must understand what you're getting back, and you must actually match the packets you send out and the replies you're getting back. And these packets sent and received usually are ICMP messages of the type echo request and echo reply. So ICMP, if you did not watch the video yet, ICMP is a protocol on layer 4. So it uses IP for transport, but it does not have anything above it. So it's basically end of the stack. ICMP stands on its own, and this is true both for IPv4 and for IPv6. So how does an echo request and echo reply look like? This is here now for IPv6. We have, of course, the standard IP header with the source and the destination IP address. We have the ICMP type, that's 1 octet, 1 byte. And in IPv6, the ICMP type for echo request is 128. So you put in 128 in the type field, you put in 0 in the code field, you calculate the checksum from the header of the packet, and you put in an identifier. You can put in an identifier, you don't have to, and you put in a sequence number. And the sequence number, well, you've seen the slide before where you send more than one ping. The sequence number basically counts up for each ping you send. And you can put in some data. The purpose of the data field is only to make the packet larger. So if you want to try with different packet sizes, you can either leave data empty and leave it 0, or you can pad up the packets to make it a bit larger to check how ping works with different packet sizes. And then we have the echo reply. The echo reply in IPv6, the type is 129, so it's echo reply 129. And the code again is 0. The checksum again is calculated from the header. And the identifier and the sequence number are copied from the echo request. So this is a mechanism that the pinging software can match basically replies to requests. The identifier and sequence number are copied from the request. And the data is also copied. So if you send out a large echo request, you get back a large echo reply. So how is it processed? And here we do have an IPv4 ping. I did not explain the header in detail because the fields are quite the same like in IPv6. You see them now filled out, so the source and destination address are filled in, and also I have filled in some identifier and sequence number. So this echo request is now sent to a system, and this system replies with an echo reply. The source and destination address are basically swapped. Yeah, of course, you just need to send the packet back. So the sender becomes the receiver and the receiver becomes the sender. And you copy over the identifier and you copy over the sequence number and the data field. And then you send it back. And that's the whole magic of how ping works and how the pinging sender can match the replies to the pings sent out. And here you see that replying to a ping, it's actually not for free. So the system which replies needs to do something. It needs to set up the reply, and this costs, of course, CPU cycles because some entity in the system has to do it, and usually that's the CPU. And the reply packet, like I said, needs to be generated, all the entries filled, and that needs to send back. And all that work is done by the CPU. That looks very trivial if you send one, but think of sending millions. Good. How now does pinging a router works? Here I have a drawing about how kind a router works. Usually what a router does, it receives a packet on the data plane, it checks the forwarding table and sends out the packet again. So that all happens on the data plane. This is very fast, and the main CPU is in that kind of work. Usually it's not involved. So it happens all on the line cards, on the ASICs, on the interfaces without involving the main CPU. But what happens now if I receive a ping? So again, the packet comes in on the data plane, and the data plane sees, oh, this is for me, this is for myself, so I have to do something with it. So first the packet gets copied somehow into memory, then the CPU needs to generate an echo reply. So like I showed, the fields need to be filled out, and then this echo reply is sent out again. And as I said, if it's one packet or two, that doesn't really matter. The CPU is powerful enough to do that. But there might be a limit because the CPU, well, it's powerful enough to process a number of ping packets, but if you think of millions and billions of pings arriving, then sometimes the CPU says, no, that's too much. I don't want to do that. And for that, a lot of routers have a limiting filter so that they do not allow an unlimited number of pings being processed. So a ping comes in and it is checked if it's still within the limit, and if it's not within the limit, it is simply thrown away and not processed. And for the sender, for the pinger, that looks like packet loss, but it isn't. So a few pings are not a problem. But if you think and millions of pings, they need to be processed, and that may overload the CPU, and the CPU has better things to do than answering for pings. It has to operate all the routing protocols, for example. So a limiter of policer may regulate the access to the CPU, and that limiter says, like I said, 10,000 pings per second are okay. If there are more, discard them. And even if a router has no limiter, the CPU is the limit, and it still may drop pings because if it's overloaded and can no longer process them. And dropped pings, they appear like packet loss because the sender doesn't get a reply because the router drops them. It receives the pings but does not process them. Conclusion. ICMP packets to a router are processed by the router's CPU, and the access to the CPU may be limited by a policer. Policed ping requests, they appear like packet loss because a reply is not sent, but they are not packet loss. And the same happens if the CPU of the router is overloaded. You should not flood ping any other entities, routers, without the consent of the network operator, because doing so might be seen as a DOS attack. But you need to monitor, or you want to monitor. What can you do? Well, there is a software called Smoke Ping. And wait, didn't I say ping is bad? No, I said massive ping is bad. Smoke Ping by default sends 20 pings every 5 minutes, and I think this is quite sensible and perfectly okay. And the results are shown in a nice graph. And if you see packet loss here, still keep in mind it can be caused by a policer because obviously all packets to the CPU are policed, not just yours. It goes usually for all ping packets received by a router. Another kind of software is iPerf3 for performance testing, and that runs on a server. So if you really want to do some performance testing, get a server at the target location, have them install iPerf3, and then target the server. Never target a router. iPerf3 is a software specifically for testing of throughput, also of massive throughput, and you can use that by starting the command on the server and also starting a command on a client and then measuring throughput. Have a look at the man page or the web page of iPerf3. If you download the slides, you will find at the end some links to it. Yeah, that's it for today. Thanks for listening. I'm Wolfgang Trammel from the DE-CIX Academy. Thank you and bye-bye.